Good morning. We are members 2613025 and 2613006, representing MCJ Cybersecurity Consulting Firm, working on the web exploitation solution for Vortican Media Sales. Let's start by addressing web exploitation. On an international level, websites are created and operated using various different kinds of programming languages. While each programming language has its own specific vulnerabilities that their users must be aware of, there are always issues showing up regardless of the chosen language or framework. Our firm is well versed in mitigating these threats through many capture the flag style practices that we have gone through. In terms of vulnerabilities, these vulnerabilities often show up in CTFs as web security challenges where we exploit a bug to gain higher access until the key is found. Like how one follows clues to look for another clue or object in a scavenger hunt. Common vulnerabilities include SQL injection, command injection, directory traversal, cross-site request forgery, cross-site scripting, and server-side request forgery. Identifying and explaining the real security problem. The servers of Vortican Media Sales contain important secure data. Currently, the vulnerabilities located within these servers have put their database at risk. With web exploitation, through problem solving and many methods like those listed, the information will be completely unsecure and available to anyone with malicious intent. However, our goal is to find these breaches and secure them. The best way to do this is to first explain how one would achieve this breach. How we would achieve the security breach. Unlike other attacks, techniques used in web attacks, or web exploitation, range from Layer 2 to Layer 7 attacks, thus making the web server susceptible to a wider variety of possible hacking attempts. Since the firewall port must be open for the web service, by default port 80, it cannot help in preventing Layer 7 attacks, which makes the detection of web attacks very difficult. Usually, in the case of web portals, the user is given an ID and a password to log in and perform certain functions, like a lot of the web portals that we know today. Portal administrators are also given their own credentials for maintenance and data management. If the web services and applications are not designed to be secure from the coding perspective, crackers can exploit those to gain elevated privileges. Like other vulnerabilities, there is some difference in the way that crackers exploit it. Often, programmers will make assumptions while setting limits for various user inputs. Typical examples are that the username should never exceed 50 characters, or that numerical values will always be positive, etc. Now, how would our team secure the breach? In this case, most website vulnerabilities that are commonly exploited are a weakness or misconfiguration in a website or web application code that allows an attacker to gain some level of control of the site, and possibly the hosting server. Most vulnerabilities are exploited through automated means, such as vulnerability scanners and botnets. Countermeasures are the same methods and techniques used by the malicious users, but are in the defensive direction. Some examples include countering cross-site scripting with cross-site scripting, or perhaps countering SQL injections with a web application firewall or input validation. Here are some other solutions. Usually, web exploitation involves custom development web applications, which include some web security flaws that must be identified and exploited. And very often, command injection, directory traversal, and XSS vulnerabilities are introduced and exploited in these categories because of their nature as autonomous web applications. Specifically, one can exploit poor security controls in a website as a regular user to gain higher level access, manipulate poor security practices in a website in order to read arbitrary data from the vulnerable server, or they could use an SQL injection vulnerability to extract the content of an intentionally vulnerable server. Now, we can also help and are well versed in many other cybersecurity areas, such as cryptography. Cryptography is the reason why we can use banking apps, transmit sensitive information over the web, and, in general, protect our privacy. However, a large part of CTFs is breaking widely used encryption schemes that are improperly implemented. If this was an issue, we as a firm would secure web traffic by changing and controlling passwords, communications, and login verification. Or we could secure the safety of copyrighted software code. Now, there is an issue with reverse engineering. The reverse engineering category often features programs from all operating systems which must be reverse engineered to determine how the program operates. Typically, the goal is to get the application to reach a certain point or perform some action in order to achieve a solution. However, we can still help by determining what input causes a program to return true, disassembling a game to find a hidden Easter egg not normally accessible, or a cheat code to make it easier to win the game, optimizing a program to make it run to completion, exploiting a buffer overflow with some security mitigations in place to gain a command shell and read a file, or exploiting a format string vulnerability to gain a command shell and again read a file. Forensics. The forensics category often features memory dumps, hidden files, or encrypted data which must be analyzed for information about underlying information. The underlying information that needs to be analyzed is the most common part of forensics. However, with this, we could extract hidden files from an image of a hard drive, extract hidden files from a memory dump, or even determine the flow of data in a packet capture to ascertain the origin or destination of data. Thank you for listening. This is our proof of completion of the scavenger hunt web exploitation on Pico season TF. This is our copyright checklist. Thank you. Goodbye.